In the last video, we discussed two different methods to measure the position of a data point, okay? One was the standard score, the another was the percentile. The next thing we want to do is we want to do the quartiles, and we also find out the interquartile range, okay? So the quartiles separate the data into four equal groups, okay? So Q1 we call first quartile, which is same as the 25th percentile. Q2 is also called the median, which is same as the 50th percentile, and Q3 is the third quartile, which is same as the 75th percentile. Because if there are so many data points in the increasing order, okay, so the quartiles divide into four equal parts, okay. So what could be those is the thing that we want to find out. So this one, the median or Q2, divide the data into two equal parts, left and right, and then the median of the left part is the Q1 and the median of the right part is Q3. That's how we find out, okay. That's very easy to find out. So what are the steps to find out the quartiles? Is arrange the data in the order lowest to highest, find the median of the data values. You find out the Q2 first, okay, and find the median of the data values that fall below Q2. From the left side, find another median, that will be Q1, and from the right side, that will be Q3, that is the median of the right side part, okay. So it says below, so you should not include that one, you should do below that and above that, all right. And the interquartile range is the difference between Q3 and Q1. Let us see one example to find out all those Q1, Q2, Q3 and the interquartile range, okay. So find Q1, Q2, Q3 and IQR interquartile range for the data this. First of all, let us arrange the data into the increasing order. Then find out the median. How many data points are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 data points, right? There are even number of data points. So there is not a single data that is in the middle. There are 2 data in the middle. Because right of these 2 data, there are 3. Left of these 2 data, there are 3. So these are 2 data points in the middle. Now to find out the single median, what you do, you find out the average of those 2. What is the average of 13 and 15? So 13 plus 15 divided by 2 is 14, right? 28 divided by 2 is 14. So 14 is the median. So what we do is you write down the 14 there, okay? So let me write down the median as a 14. So let me erase that one as well. So median is somewhere here. 14 is the median. 14. Okay. Now to find out the Q1, you look at the data left of 14. And then find the median here, and then for the Q3 or the third quartile, you look at the data right of that. Okay, so let's find out Q1. What is Q1? Then how many data are left of 14? 1, 2, 3, 4. So what is in the middle? So there are 2 data in the middle. So find out the average of those 2. So what is the average of those 2? Is the 9, right? So 9 is the Q1. And similarly here, there are 4 data on the right of 14. And then there are 2 in the middle, right? So what is the median? Then the average is the average of these 2 is the median, right? So that will be 20. So Q1 is 9, Q2 is 14, and Q3 is 20. You see that? So 9, 14, and 20. Now how do I find out the IQR? Is Q3 minus Q1 is 20 minus 9, which will be 11. Okay, this is how you find out the median Q1, Q2, and Q3 by hand. But if you enter this data in your calculator find out all Q1, Q2, Q3 directly, okay. So how do I do that? Again, the same way how you find the mean. Stat, edit, and enter, and then press enter. After you do that, you will get L1, L2, L3, and so on, and enter the data. 15, 13. You don't have to sort the data in increasing or decreasing order. If you are using the calculator, you just enter the data, raw data in the calculator, and so on, okay. And then after you do that, stat, calc, and then one variable status, right? After that, one variable status, statistic, okay, one variable statistic, and hit enter. Then again, if you have a TI-83, if you enter the data in L1, you don't have to do anything. But if you enter the data in L2, then you need to write a curly braces and L2. How do you do the L2? Then alpha 2 will give you L2 there, okay. Now So this is what it is given. So if you scroll down, when you do hit enter and scroll down, you will see the Q1, Q2, Q3 minimum maximum values. But if you're using TI-84 though, when you do stat, calc and one variable status, it will ask X list and frequency list. Okay, X list should be L1 because you enter the data in L1. If you enter the data in L2, your X list must be picked L2 there in X list. Okay, all right. So this is an example. You can do the example by yourself. First, sort the data in increasing order, find the median, okay, and then find the median left of, find the median of the data left of the real median. So median will be Q2, and the median left of the Q2 will be Q1. Similarly, the median right of the median of the data that are right from the Q2 will be Q3, and so on. The next thing you want to do is outliers. You do yourself, okay, on this example. An outlier is an extremely high or low data value when compared with the rest of the data value, or data value less than Q1 minus 1.5 times IQR, or greater than Q3 plus 1.5 times IQR, interquartile range, that is Q3 minus Q1, right? Can be considered an outlier. This is just one way, but people use other different formula. This is most commonly used formula. So if a data is 1.5 minus Q1, if a data is 1.5 IQR below Q1 or 1.5 times IQR above Q3, then those data are considered an outlier. Let us see an example. On this example, is there any outlier? That's what it is asked to check. Here this is the same example as example 5, okay? This is same as example 5. The data is same. So we find out Q1, Q2, Q3 already. Q1 is 9, Q2 was 14, right? Q3 is 20, and IQR we find out 11. So what is 1.5 times IQR? Is 1.5 times 11. That will give you 16.5. Okay, now what is Q1 minus 1.5 times IQR? That is the formula. We got negative 7.5. And this one plus will be 36.5. What does it say is any data value that is below negative 7.5 here, that is below negative 7.5 and above 36.5 are outlier. Okay, so this is the outlier actually, because that data is more than 36.5. So this is the outlier. Okay, so this is how you find out the outlier. All right, guys. So you know that, do you remember we said that when you find out the mean, if there is a very, very, very big data, then the mean is affected, because when you find out the mean, you add the data, and adding a big number makes the average bigger. Okay, so if the sample size is big enough, if there are a lot of value in the sample size, but if there is one or two big outliers, so the best idea would be you can remove that outlier. Okay, you can remove that outlier and then find the mean of the remaining data only. That's what usually you do when you are doing the data analysis. Okay, example 8 is find the outliers of this data. Again, you need to find out, write this in the increasing order, find Q1, Q2, Q3, also find Q3 minus Q1, that is IQR, right? And find out 1.5 times IQR and find the numbers. You do Q1 minus that thing, and then Q3 plus that thing, and then any data lies below or above above those two numbers will be the outliers. Okay, you do this example yourself. The last section is exploratory data analysis. We say EDA. Usually we find out the 5-number summary for that. Developed by John Tukey, the purpose of EDA is to examine data to find out what information can be discovered about the data, such as center and spread. For center value, it uses median, and for variation, it uses interquartile range. To graphically represent dataset, it uses Boxplot. A Boxplot involves 5 specific value called 5-number summary. Okay, so we are about to draw a Boxplot, meaning the summary of the data, we want to put that in the figure, in the picture. Okay, so to find out the Boxplot, to draw the Boxplot, we need 5-number summary. What we need to note is the smallest value of the data. We need to find out Q1, you need to find out Q2, Q3, and then the highest value of the data. So how do we construct a Boxplot? Is write the data in ascending order, find the 5-number summary. What are the 5-number summary? Minimum data, Q1, Q2, Q3, and maximum data. Okay, draw a horizontal axis with a scale that includes the minimum and maximum data values. Draw a box with vertical side through Q1 and Q3, and draw a vertical line through the median. Draw a line from the minimum data value to the left side of the box and line from the maximum data value to the right side of the box. The example clarifies all those things. Okay, you want to draw the box plot, construct a box plot of this data. So first of all, order the data or sort the data, increasing order. That's good. Now find out Q1, Q2, and Q3. Q1 is 47. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points, right? So if there are 10 data points, then there will be 2 data in the middle. That is the middle data. Now to find out the median, Q2, you find out the average of that. That's what you find out, 83.5. So 83.5. That is the median. Now all the data left of that median, will be used to find out the Q1. So find the median of those data. 1, 2, 3, 4, 5 data. So this is the median. So for Q1 is the median of the left data only. That is the Q1. Similarly, this one will be the Q3. Now what is the 5-number summary? Smallest data, Q1, Q2, Q3, and biggest data. So to draw the box plot of this, what we do is draw a line. So the smallest data is 30, biggest data is 296. So just to see them, I started from little smaller than the smallest data, 0, and little bigger than the biggest data, 300. So I mark that into 3 equal parts. So 0, 100, 200, 300. You can do 0, 50, 100, 150, 200 that way too. It's not a problem. Okay. So and then like that. Now to draw the histogram, what you do is mark the dot for the lowest point, highest point, Q1, Q2, Q3. Now you need to make a box between Q1 and Q3. What do? Draw the box on there, and then draw a vertical line from the median as well. Now this is the box plot. Okay, from the box plot you can actually check the shape of the distribution of the data. You see that? So which box is bigger from the median? The right side is bigger, right? That means it is right skewed. If the left side is bigger, that will be left skewed. Okay, if the both sides are equal, if this box and that box have the equal size, then we call symmetric or bell shaped. That's what we can say about the from the box plot. Okay guys, so let's see. If the median is near the center of the box, the distribution is approximately symmetric. If the median falls on the left of the center, then the distribution is positively skewed. That's what it is, right? Because the center will be somewhere here, right? That will be the center. You see that? So the median is on the left side of the center, so it will be right skewed or the positively skewed. If the median falls to the right side of the center, then the distribution will be negatively skewed. Also, if the lines are about the same length, the distribution is approximately symmetric. That is another way. If these lines are approximately the same length, then it is symmetric. If that line is longer, if the right side line is longer, then we call right skewed. If the left side line is longer, then we call left skewed. That's what it is saying. Okay, that's all. Alright guys, this is the end of chapter 3. So next video will be chapter 4. Thank you.